Since we have discussed what an electric dipole and an electric dipole moment is, now what we'll do is take this system and try to define the electric field due to this kind of a system at two important points. Okay, I'll tell you what they are. So, if I take this dipole, now this is a charge and this is a charge. So, both the charges will have some effect of electric field in their surrounding. Accepted? So, this can generate some value of electric field in the surrounding, this can generate an electric field in the surrounding. The system as a combined factor can create a net value, right? Now, we are going to see how much is that net value going to be at two different points, where one of the points is going to be called as axial and the second is called as equatorial, right? So, here as the word suggests, what is axial? It is the axis, right? And what about equatorial? We'll see it when we go to the topic, right? So, now the topic of discussion is going to be electric field due to a dipole at axial point. So, electric field due to a dipole at axial point. So, if I take this to be the positive charge, this to be the negative charge, right? So, here what do I mean by axis of a dipole is an imaginary line that is joining both the charges. So, how is it going to look like? It will be something like this. So, this is what is called as an axis. So, when I take this axis, right, generally what you do is you can calculate it three different points. One is here on the left of both the charges, between the charges, or on the right of both the charges, right? We generally don't do between, okay? We'll take on either of the sides. So, in this scenario, let me take it on the left of both the charges, where I will call this point as capital P, not to get confused with dipole moment. It is just a point, okay? And if you remember, I wrote the distance between both the charges not as A, right? When we wrote the definition for dipole moment, what did we write? We wrote it as Q into 2A. So, the reason why we wrote the 2A is because we have some mathematical use of it, right? So, this point P is there, right? For that point, you need to measure the distance with respect to some reference point. So, when I say reference point, you can take either from positive charge or negative charge, but with respect to a dipole, always the reference point is taken to be the center. So, when you take it to be the center, what did we assume the distance to be? 2A, right? Now, you can break it as A and A. That is the advantage. Okay. So, this distance is going to be A and this distance is going to be A, right? And the distance from the center to the point where you are calculating the field, let's call it as R. Am I clear till this point? Right. Now, what is going to be the distance from the positive charge to this point P? How much is this distance going to be? Obviously, R minus A, right? So, obviously, from the negative charge, how much is it going to be? It will be R plus A, R plus this A. Okay, let me call this as A and let me call this as B, right? So, I already told you one thing, electric field is always calculated at a point. So, when you write it, no, you need to write it like this. Electric field at P, the first one is due to A. What is it going to be? It's very simple. You go back and see the mathematical expression. It is very simple. Take the magnitude of the charge, right? Take the magnitude of the charge divided by 4 pi epsilon naught into distance square, right? So, having said this, what I'll do is, here also I'll do the same. The magnitude of the charge is Q, I'll call it as EA, okay, electric field due to the charge at A. So, it is going to be Q divided by 4 pi epsilon naught into what square? The distance square. So from this charge to this point, what is the distance? R minus A the whole square, right? So the next thing is, whenever you're dealing in physics, right, you need to see whether the quantity is a scalar or a vector. Here I'm dealing with electric field. Electric field is a vector quantity. So for this, I first wrote the magnitude. Now what I'm going to do is I'm going to assign a direction to it. So for that, I'll put a bar on top of it. Right. Now I'll call it as EA vector. Right. So from the definition of dipole moment, we know that the dipole moment in this scenario is in this direction. It is from the negative to the positive charge. Right. Electric field due to the positive charge at point P, is it in the leftward direction or rightward direction? It is leftward. Why? Because due to a positive charge, the electric field is always away from it. So this is the direction of away. Right? This is away, this is away, this is away. It keeps going like this. So I'm talking about this point. So it is in the leftward direction. So can I put it like this? EA. Right? So compare the direction of EA with the dipole moment. Are they both in same direction or opposite direction? Same, right? So can I put it as P cap? Makes sense? So what did we do? It's very simple. First, I wrote the magnitude part. What does the magnitude part speak about? Magnitude of the charge divided by 4 pi epsilon naught into distance square. What is the distance? From where should you take the distance? From the, not from the center, from the charge to the point. If you take it from the center, both the cases you will write r square. No. You should take it from the point, from the charge to the point. So it is r minus a the whole square. Then put a bar on top of it and give the direction. So try to write the direction in terms of dipole moment. Okay. Next question. Due to B, EB is equal to, what will you write? Should I write Q or minus Q? You should write it as Q only. So wherever you're dealing with vector, never take the sign of the charge into consideration. So Q divided by 4 pi epsilon naught. Very simple. Now you tell me R plus A. Simple, right? So the electric field due to the negative charge at point P. So if I keep a test charge here, this is how you need to visualize. If I keep a test charge here, by default test charge is positive. Will it get pulled towards it or repelled away from it? It will get pulled, right? So what should you write here? This should be the direction of EB. Makes sense, right? So if I put a bar on top of it, if I call it as EB vector, then in terms of the direction of EB and dipole moment, how are they? Opposite. It is a negative of it. So I'll write it as minus P cap. Makes sense, right? Now, you observe this is a vector quantity, there is another vector quantity. So what is going to be the net electric field at P? So it is going to be EA vector plus EB vector. Here also I need to put a vector symbol. This is basically the principle of superposition, right? So what is EA vector? Take this into consideration. Q divided by 4 pi epsilon naught into R minus A the whole square, and don't forget the direction. It is going to be P cap, right? Plus Q divided by 4 pi epsilon naught into R plus A the whole square, which is going to be the direction of minus P cap, right? Now I'll bring this minus outside for the mathematical operation so that I can take out P cap common. So what I can do is, can I take this Q by 4 pi epsilon naught outside? So Q divided by 4 pi epsilon naught if I take outside, I am left out with 1 divided by R minus A the whole square inside due to this, and due to this I am left out with minus 1 divided by R plus A the whole square. So what is going to be the common thing? It will be P cap, because I took the minus sign inside and took P cap outside. I hope it is clear. Right. Now the next question is, it is going to be q divided by 4 pi epsilon naught. If I take LCM, they get cross multiplied. So r plus a the whole square minus r minus a the whole square, the whole divided by, observe, this a minus b into a plus b form. It's a square minus b square. R square minus a square, but the thing not to be forgotten is both are whole squares. So r square minus a square the whole square. Now close the bracket and write it as p cap. Is it clear till this step? Right. So there are two more steps. We'll finish it. Then you can copy. Right. Now observe. A plus b the whole square minus a minus b the whole square. What is it going to be? A plus b the whole square minus a minus b the whole square. What will get cancelled? A square are gone, b square are gone. 2ab will get added to 2ab, which will give you 4ab. Okay, so it's very simple, right? A plus b the whole square minus a minus b the whole square is a square plus b square plus 2ab minus of a square plus b square minus 2ab. A square and this a square are gone, b square and this b square are gone, 2ab will get added to 2ab. So it will give you 4ab. This is an identity, right? Next time you can remember it, right? So what will happen here? It should be 4 times a into r. Here a is r, b is a. So 4 times ar, right? So it will be q divided by 4 pi epsilon naught into, just to understand, I am writing this again, r plus a the whole square minus r minus a the whole square divided by r square minus a square the whole square times p cap. This is what you are going to get. So q divided by 4 pi epsilon naught into, here it is going to be 4 times ar divided by, this is where we need to be careful again. Remember, R is very much greater than A. The reason being, I told you, we'll not calculate it in between the charges. We always calculate on either side of the charges. Here we are calculating on the left of it, or you can calculate on the right of it. So when you do this kind of a scenario, the distance R you are taking, no, it is actually a value very much greater than the distance of separation between the dipole, because dipole is a very small device. Okay, it's like a, they are separated by a very small distance, right? Whereas the distance you are going to take r from the center is going to be very large compared to this distance. So r is very much greater than a, which implies r square minus a square can be approximated to r square itself mathematically, because this value is already greater than this. If you square the values, this value will become even more greater, right? So r square minus a square is approximated to r square itself. So what I can do here is r square minus a square I'll approximate it to r square minus a square. R square minus a square I'll approximate it to r square. So r square the whole square, it will become r power 4 times p cap. Clear? So 1r will cancel the 4 here. So it will be left out with r cube in the denominator. Right? Now, this 4a is there, no? This 4a, how I'll break it as 2 into 2a. So when I do that, can I write it as 2q into 2a divided by 4 pi epsilon naught r cube times p cap? Can I write it like this? Right. So this q into 2a is going to give us what? We can condense and write it as another value. What is it? It's called the dipole moment. So I will write this as 2 times the dipole moment divided by 4 pi epsilon naught r cube times p cap. Right. Or what you can do is you can write it as 2 times this 1 by 4 pi epsilon naught, you can call it as k into p divided by r cube times p cap. See, both are the ways in which you will find it in some of the books. Okay, both ways are accepted, and this is going to be the value of electric field due to a dipole at an axial point. Okay, here one important point to be noted is, I took this point P on the left hand side, right? And what is it we got? the direction of the electric field as. We got it in the direction of dipole moment. So what do you think will happen had I taken this point on the right hand side? What do you think would have happened had I taken this point on the right hand side? So it will still be in the same direction. Are you able to understand? So here what is the important point that we need to make a note is electric field due to a dipole at axial point. This is the word we need to make a note. At axial point is always in the direction of dipole moment. It is always in the direction of dipole moment. Right? This is a very, very, very important point to be noted. Right? So is it clear? You understood this approximation, right? So everything is clear? Okay. So now we can make a note. What I would suggest is, since there is a derivation, it is important. Just go through it once, try to do it on your own. Okay, whenever you get stuck, look at the board. Don't copy blindly.